Code agents help you build a right code very quickly after you specify your intent. So these agents help you improve your coding productivity by, for example, getting rid of boilerplate code. You don't need to write the code agents take care of it. But boosting code productivity isn't just about not writing boilerplate code. It's rather about accelerating the evolution of your design. Yeah. So as you write more code, the design isn't really static. As you write more code, the design evolves and you discover your design intent in an iterative way. So let me take you through an example of this evolving design pattern, or what is called emergent design, and then we'll discuss more about it. So here's a quick example. You want to analyze your log files. You're looking for sentences which contain the word errors. You want to find out points where the error happened. And so this is simple code, extract errors, and it just looks for the pattern error. The output that you get are lines like these. So once you implement this, you realize that you are not looking for all kinds of errors. You want to discover the critical errors. So you want to prioritize discovering the critical errors, and so you go back and modify that function. Now, how do you identify the critical error? They have phrases, they are specific phrases, and now your code evolves to just look at those phrases, and the output now only has error lines which contain those phrases. Now, once you get this out, this is a bit satisfying, but you realize that no, this is just raw text. You want the output in a more structured format. So this is you want timestamp and the error message. You don't specifically need the whole raw text. You just need the reason behind the error and the timestamp. So you go back and introduce a regular expression, matches with the line, split the line into timestamp and the message, and then output these logs. So that's how this discovery happens. Once you write the code, you discover your intent better, and the intent isn't all of your intent is not apparent in the beginning. So you need to write code and observe the outputs, and only then you discover. And the design evolves to better align with your intent, right? So we start with just error lines, and then we prioritize critical errors, and then we want structured data. And yeah, so let's continue and see some more. So when you do it in a real life scenario, you find that the logs can be massive, and if you read all the log in memory, is not good. So you want to read line by line from the disk. So you modify. You go back to the original matching function. You match a bunch of error keywords. Generalize that function. I take as input error keywords, and while you open the file, you read for each file directly from the disk, and you output that. The next stage of evolution might be that once you start getting lots of these errors, there could be many such huge amount of such logs, also even critical errors. So you want to filter them down into a particular time period. So introduce start time and end time. Now, after we have narrowed down errors into a specific time frame, we get more manageable logs, but then realize that there's still too many errors, and it would be good to group them by the error types or categories. So introduce a network category, and you introduce authentication category, and and then the code evolves to accommodate those categories, right? And so now we have grouped logs. That's great. What we get this logs by a post hoc analysis, but it would be better if we get immediately notified when a critical error happens. So you add alerts and monitors to your code so that you get immediate notification. And finally, now you get good logs, you get alerted, but you don't want text logs. It's better to visualize those errors and the error frequency and trends and so on. So you add some charting on top of the errors to get these get nice visual logs. So note how we evolved from a very basic error matching matching logs with just error keyword to a full-blown visual error reporting system. Right, so this is the process of emergent design, where we start with a basic implementation that just seems to satisfy the immediate goals, and then realize that our intent or business needs are greater and we need to evolve the code. But we add features only when a real need emerges, so that avoids over engineering also. And it's useful to note what causes these refinements at every step. There are a couple of reasons. For example, scalability. We wanted to analyze all the logs on a huge amount of logs on the disk, and it wouldn't be a good idea to load it in memory. So the design evolved to accommodate that. Finally, note that we are doing incremental refinement. Code continuously evolves to satisfy our business needs. So as a takeaway, as you write more code, your ideas and your intent also gets refined with it. You move closer to your intended outcome with every refinement. And this is an iterative process of discovery of intent, which also matches your business requirements. And this the key question is, how do we, if we want to be really productive with code, how do we really streamline and speed up this discovery phase? So instead of just coder agents filling up pieces of boilerplate code for your coding workflow, what you really need is to look ahead in your design and to be able to do this design refinement or intent refinement far more quickly.